So inverse sine has a domain from -1 to 1 and a range from, and that's our quadrants 1 and 4, -pi/2 to pi/2. So I'll stop there and I'll jump right down to B. So what you saw in your homework and you're going to see more of is an inverse sine up against a sine, or like the composition of a sine with its inverse, or a cosine and its inverse. And last year you learned with basic functions that f inverse of f of x, so if you compose a function with its inverse, they essentially undo each other, right? So whatever you plug in, x, is what you're going to get back. So the idea is that, oh, they just cancel. Inverse sine and sine just cancel. Inverse cosine and cosine just cancel. And that's, loosely speaking, what happens, but you have to be careful of situations like this. The domain of sine is what? We'll go to the regular sine. What's the domain of just regular sine? All real numbers, so -infinity to infinity. The range of sine is -1 to 1. So on this particular one, the sine of 3pi/2 is not a non-issue because it's all real numbers, so that's fine. What is the sine of 3pi/2? What did you say, pi/2? It's got to be a number between -1 and 1. It's either 0. We're not doing an inverse sine here, Stephen. We're just doing a straightforward sine of 3pi/2. -1. Okay, so maybe it would help to visualize terminal ray here. Sine of 0 is 0. Sine of 90 is 1. So the 3pi/2 would be -1. You can think about your coordinates, 0, -1. Take the y coordinate, but that's -1. So then this would become inverse sine of -1. And then because inverse sine only has a range between -pi/2 and pi/2, so going this way or this way around our unit circle, which angle in the -pi/2 to pi/2 range has a sine of -1? Right. Sine of some angle has to equal -1, but our angle has to be in between -pi/2 and pi/2. So the answer here is pi/2, -pi/2 rather. So you can't just cancel here, right? It appears that way in a lot of them, but you can't just quote unquote cancel sine inverse and sine like you can here because of these domain and range restrictions. -pi/2 is the same terminal ray as 3pi/2, so that part works out, but you have to give the angle that's in the appropriate range. So it's almost like it seems like a trap. It's not meant to be, but it does obviously seem like it's a little tricky, which it is. Just be careful of that. Yeah. You can, but there's going to be another tricky thing to think about too. So yes, if you want to do that, that's fine. If I do the cosine inverse info, remember the domain is -1 to 1. And the range, what quadrants are we in? 1 and 2, so 0 to pi. And then the basic cosine curve has a domain of all real numbers again, and a range of -1 to 1. Okay, so on this A versus C, do you first and foremost notice how in A and C, the inverse cosine is the first function that we're going to do? As far as the order, when you go through these, you're going to first take the inverse cosine. You're going to first take the inverse cosine here. This one happened to be, we took the sine was on the inside as opposed to the inverse sine. So this was okay because the domain for just a plain old sine function is all real numbers. So we had no issue taking the sine of 3 pi over 2. One of these we cannot do. So even though the instinct and the I guess what you might be tempted to do is just cancel this, answers 0.6. Cancel this, answer is 1.5. But one of those you can't do, because the domain for inverse cosine, same for inverse sine if we ever had it in this order, you can only take the inverse cosine of things that are between -1 and 1. So which one of these does not exist? C. And in parentheses for you to remember, 1.5 is not in the domain of inverse cosine. Okay. In part A, if we think this through, let me kind of wrap my head around this myself. You're taking the inverse cosine of 0.6. That's okay, right? And it's going to get you an answer in the range of 0 to pi, right? So then when you take the cosine of something that's between 0 and pi, you're going to get an answer that's also between -1 and 1, right? When you take the cosine of something between 0 and pi, cosine of anything you're allowed to take, you're going to get something that's between -1 and 1, which will be 0.6 exactly. So these kind of do just cancel. But honestly, it's probably almost going to be more often that they're not going to just cancel for some reason, meaning it wouldn't just cancel because something about it doesn't exist and is out of domain, or it wouldn't just cancel because something is out of range. You've just got to think through each piece of this. How come no one told me I screwed up my domain up here? All right, so a little twist to think about. So I tried to put together all of these scenarios, and this will just cancel, but only when x's are what? Yes, only when x's are, did you say less than or equal to 1? Well, we can only take the inverse sine, and that's what's on the innermost portion of this composition. We can only take the inverse sine of numbers between -1 and 1. So this will only be true if we're looking at x's between -1 and 1. I'm going to jump down to the third one because I want to address all the ones that have the inverse cosine on the middle or on the inside. This is going to be the same for x's in the interval -1 to 1. Because for inverse cosines, we can only take the inverse cosine of things that are between -1 and 1. So as long as that happens, those will appear to just cancel. The sine and the sine inverse, the cosine and the cosine inverse. What about tangent? Let's go back up here. I'll get rid of this. And let's remind ourselves what happened with tangent on Friday. So what was the domain of the inverse tangent? I'll give you a reminder of what the graph looked like. right. So that was all real numbers. And what was the range? Negative pi over 2 to pi over 2, quadrants 1 and 4 again. Not including what? Oh, yeah, you're right. Parentheses, thank you. Because they're asymptotes. Good. And the regular tan graph has a domain of, this is kind of harder to write, obviously, but all real numbers except what? Odd pi's over 2. So let's do x can be any real number except x cannot equal k pi over 2, where k is odd. That's a mouthful. And your range is negative infinity to infinity. Good? Any questions on that? I would say a lot to memorize, but then I would follow that up with, which is why I wouldn't memorize them. Because they're all so closely related and also sort of, I guess, confusing that the best way, in my opinion, is just to know what the graph looks like and then just think through the domain based on that visual thought of the graph. So back to this tan of the tan inverse of x, since the inverse tangent of x has a domain that's completely unlimited, we can plug in anything. We're going to get some answer that's between negative pi over 2 and pi over 2. So then when we go to take the tangent of something between negative pi over 2 and pi over 2, we are going to get back what we started with. So this is going to be true for all real numbers. Really, because we can take the inverse tangent of any real number. And again, I did those three first because those all have the inverse function in the inside. Okay? On the sine one, and I'll do the obviously cosine tangent, they all have the plain old function on the inside. You can take the sine of anything, right? And you're going to get something between negative 1 and 1. But then when you take the inverse sine of that answer, your inverse sine has a range, quadrants 1 and 4, between negative pi over 2 and pi over 2. So this will only perfectly cancel because our answer has to be, the final step of all this will be taking the inverse sine of something. We have to get something between negative pi over 2 and pi over 2. So the only way it will equal what the original x was would be for any x's in that interval, negative pi over 2 to pi over 2, which sort of explains why example B did not work out as being a cancellation, because this original x value was not in that interval. If it had been, it would have been a straight cancellation. Inverse cosine logic is going to be the same. So this will only be a cancellation if that x is in the interval from 0 to pi. I'm just going to do this. And then what about tangent? Same thing, same logic. Inverse tangent, no matter what we're taking, whatever this ends up being, who cares? The inverse tangent of anything has to be between negative pi over 2 and pi over 2. So the only way it's going to appear to be a straight cancellation and x is just going to be the answer x is for x's in the interval from negative pi over 2 to pi over 2. Yes. Sorry. Okay, again, a lot to memorize. I wouldn't really memorize it. I would think it all through, but I think it maybe helps to see how the order matters and how finicky it is with whether or not these will just cancel each other off. Because, did you do inverse functions like this last year? Did you do compositions? No? You just always switch the x's and the y's? You did it with this. Oh, you did. Okay. So you talked about if things are truly inverse functions, you'll just get x back. And it is true. It's just with trig, there's a lot of tricky little pieces that we have to think about. Okay? Any questions? Okay. So we'll do some more compositions. This is going to be different, though, because we've got a mixture of functions, a cosine with a tangent inverse for starters. And then you'll see that we won't actually ever know what this value is, okay? When we're asked to come up with this, when you're working inside out, we are essentially asking the tangent of what angle is going to equal 5 over 12. We are never going to know what theta is. The good news is we don't care, okay? Because at the end of the day, they're not asking us for theta. They're asking us for the cosine of whatever that theta is going to be, and that we can do. So given that they're telling us that the inverse tangent is 5/12, what quadrants am I limited to with inverse tan? 1 and 4. So specifically, if the tangent of this theta that we're talking about is positive, is it quadrant 4? 1. So we're going to draw a terminal ray and an angle theta in quadrant 1. We're going to label our sides appropriately. So the opposite is 5 over the adjacent is 12. We're going to complete the triangle. So what's the hypotenuse? 13 with the Pythagorean theorem, or Pythagorean triple there. And so we don't ever know what theta is, but we know kind of the type of triangle that it's in. And so at the end of the day, they're just asking us for the cosine of that angle. And the cosine is the adjacent 12 over the hypotenuse 13, and that's your answer. Does this make sense? So that intermediate step of, well, what's the measure of angle theta? We don't care. We can't find it without a calculator, and we don't care. Try the next one on your own using that same logic. Raise your hand if you're done. Okay, take your moment. Now raise your hand if you're down. Straight elbows, so I can see. That's not a straight elbow. Yeah, but I can't see it. Perfect. Let me kind of more importantly get to the bottom of the confusion. So, Winter, what have you done so far? Well, inverse sine, look at your domain, has to be between -1 and 1. Is that between -1 and 1? It is. So essentially what this innermost part is asking us is the sine of what angle equals -1/3. So based on the range of inverse sine, Winter, what quadrants am I limited to? Nope. Look at your range of inverse sine. 1 and 4. -pi/2 to pi/2. So in which of those quadrants, all students take calculus, in which of those quadrants is the sine a negative number? 4. Okay, so I'm going to draw a terminal ray in quadrant 4 and label that my theta. And my opposite should be labeled what? -1 over my hypotenuse 3. So the Pythagorean theorem, what squared? Hypotenuses are always positive. X squared plus the y of -1 squared equals 3 squared. So this is going to be 1, subtract 1 from both sides. X squared equals 9 minus 1, which is 8. And the square root gives us 2√2. So again, I don't know what theta is, but I do now know that I can come up with the cotangent of theta. And that is not opposite over adjacent, but adjacent over opposite. So 2√2 over -1. So your answer is just -2√2. Raise your hand if you got that. Good. Oh, that's okay. Well, we do need to simplify. It probably in a multiple choice wouldn't be radical 8. Any follow-up questions on that? Okay. So if 0 is less than x, which is less than or equal to 1, write the cosine of the inverse sine of x as an algebraic expression in x. So they are looking for the sine of some theta having to equal x. And since x is what? A positive number? What quadrant are we in? Quadrant 1. So here's my triangle. There's my theta. The sine is just x. So that's opposite. Well, technically I'll put it over 1. How's that? Opposite is x over hypotenuse will make 1. So we're going to solve for this missing side. It's just going to be in terms of x. So I'll use a new variable a for the moment. So I can solve for a squared plus x squared equals 1 squared. I'm going to subtract x squared from both sides. I'm going to square root both sides, which technically I need a plus or minus, but what do you know? Is the a coordinate positive or negative in that quadrant? Positive. So I'll just keep the positive 1 minus x squared. So that a value is truly, in terms of x, the square root of 1 minus x squared. So again, I'll never know theta, but now I can find the cosine of theta. It's the adjacent, which is that radical, over the hypotenuse 1. So my answer is just root 1 minus x squared. Does that make sense? Just have to swallow that and do it in terms of x and not actually have numbers. Try the second one here based on that logic on your own. Raise your hand if you're done. Okay, Haley, where are you at? What have you done so far? Good, because we're starting with the inverse tangent of x. And they told us that x is positive, so that's the tangent of some theta equals x. So this fact that x is positive tells us tangent is positive, which happens in the first quadrant. Good. How did you label your triangle? Great. Okay, so if I do the Pythagorean theorem, x squared plus 1 squared equals hypotenuse squared. So that's x squared plus 1 equals hypotenuse squared, and I have to take the square root of both sides, right? And you took the square root of each piece of the polynomial individually. Can't do that. Okay, you cannot, just like when you raise a polynomial to an exponent, x plus 3 squared, you don't square both pieces and be done with it. Okay, radicals are just like exponents. You can't take the square root of each piece individually. So we just leave it like this. But you're pretty much there because now we can just take the secant of that theta, which is not cosine adjacent over hypotenuse, but the reciprocal of that hypotenuse, root x squared plus 1, over adjacent 1, which we don't really need, but I'll document it anyway. And there's our answer. Any questions on that? Same stuff we did on the front side, just dealing with variables. Okay? Down below, determine the domain and range of each function. Well, for part A, the domain is going to be the same as it was for inverse tangent, which is all real numbers. Honestly, my mind immediately envisions the parent graph of that. So all real numbers. The range, however, because this got vertically stretched by a factor of 2, okay, and then horizontally flipped, although that's not going to really change our range, what is our new range? Negative pi to pi. Good. with parentheses because those are technically asymptotes. It used to be negative pi over 2 to pi over 2, but I doubled that out vertically, and then when I flip it, not going to make any difference. Good? And B. What is our domain? Because what are we allowed to take the cosine of? What'd you say? Just innermost. Negative 1 to 1. And our range, because it's the range of our outermost sine inverse, is negative pi over 2 to pi over 2, because that's, no matter what we plug in, we're going to get something that's between, well, it could be anything, right? Wait a minute. We screwed up. I believed you, and I shouldn't have. What is our domain? What numbers are we allowed to take the cosine of? Anything. We don't have a limited domain. We can take the cosine of anything. Our answer for the innermost part is going to be between negative 1 and 1. And because that's going to be between negative 1 and 1, we will always be able to take the inverse sine of that number, and our answer will be somewhere in quadrant 1 or 4, negative pi over 2 to pi over 2. Just because I'm curious. Just because I want to see this graph. See what our calculator does with it. Inverse sine of the cosine of x. What window should I do? Well, since we told me my domain was negative infinity to infinity, I'll go negative 10 to 10. Since my range you told me was negative pi over 2 to pi over 2, I'm going to go negative pi to pi. I'll count by pi over 4 or over 2. So were we right? Domain negative infinity to infinity? Yes. Range negative pi over 2. That's the minimum to positive pi over 2. Never seen that before.
Well, I have.
Pretty graph.